Hello, I hope you're all great. And you're having wonderful times. So let's start today's class. So let's see where we are now. Like we are almost done with auto transformer, and today I'm supposed to give you one quiz, but I thought to myself that let's not focus on quiz one for today. I rather focus on other thing because a few of the students actually reached out to me and requested to have a lecture on MATLAB Simulink because they don't know how to use it. So I was thinking to do a exercise on MATLAB Simulink, and I will share few examples of MATLAB Simulink to like tutorials or exercises so that you can actually understand. So the quiz one will be like an assignment. So it will be like on next class. So next class we are not gonna focus on the three-phase transformer this topic. We rather will focus on quiz one, which will be on MATLAB Simulink because few of you are struggling with it. So I don't want to go ahead and do all the stuff without actually having concrete understanding or at least a base of understanding of what we're doing. Because in future experiments, we are going to actually need MATLAB Simulink and we need to understand how it works. At least you don't need to design anything or anything, but you need to know how to use it. So in tomorrow's class, or sorry, next week's class, I will be focusing on that, and today's class, I will be talking about auto transformer. So, okay, so auto transformer is experiment number 7. So auto transformer, I'm not gonna go deep into the what is it called theoretical part. Rather, I will show you the figures. Let's open this one. So auto transformer is a transformer which has only one winding. Say for example, this is one of the windings of a transformer. If we uh, bring it somewhere else and take points from these different nodes, these are the different nodes of that auto transformer. We call it in terms, we call it tap out. So we tap from different points. Say, for example, we have 100 turns here, and we're supplying from the left-hand side, which is the primary side in this case. So we have 100 turns, and if we supply 100 volts here, we'll get 100 volts on from this point to that point. That mean that means that each of the turn will have one voltage. So if we supply 200 volts, in that case also, for each turn we'll get 2 volts. So if we take half of it and tap out, like say for example, we take this point and connect it to the secondary side and take the bottommost point from here, we take another point. So that will give us 50% of the winding. That means we'll have on the secondary side, we'll have only 50 volts. If the supply voltage is 100 volts. So with this arrangement, we can actually make the step down transformer. Uh, Again, if we supply it from the secondary side, so if the supply in will be here at that point, and from that similar point, if we like from middle point, if we supply and if we take voltage measurement on the primary side from this point, at that uh, at that case we will get like 100 volts here, and we'll if we supply 50 volts we'll get 100 volts. That means at that case transformation ratio will be um, 2. So today's experiment is very simple. We will see some of the different cases, circuit arrangements where we'll connect different setups. Like for instance, sometimes there will be some taps on the primary side and on the secondary side. First, we'll test with different um, arrangements for two winding arrangement, and in some cases we'll check one winding arrangement. So there are we have actually selected 12 cases where we'll connect the supply side with one arrangement and load side with one arrangement. In some cases we'll use both of the winding. In some cases, say for example, case 4 and case 5 will only use the primary side. There won't be any secondary side. So primary side will have in one of the sections will have supply connection, and one of the sections will have load side connection. Say for example, we'll supply the whole winding in some cases. In this case, case 4 and case 5, we're going to supply the whole winding, and we're going to take a portion out of the same winding and feed it to the load. So in this case, we're gonna consider only R load, because the purpose of this experiment just to see whether it works or not, that whole auto transformer concept, whether it works or not. So we'll test that, and we'll measure this values and take notes and calculate the transformation ratio, and we'll answer some questions. And if we look at from case 7 to 12, we'll see it's all about auto transformer cases. Actually, from case 4 to case 12, with different arrangements, different permutation and combination, we have selected these cases and we'll test them. So I have already experimented that one. Let me show you that video. So you will take note, and I will provide you that table. This table. Let's watch the video. So this is the test setup. So we are gonna test the auto transformer case here. So there are 12 different cases that we are gonna test. So if we look at the table here, so we'll have a supply side and a load side. So supply side is in the second column and third column is load side. So we're gonna connect our transformer to the power supply with this indication or instruction, and we'll connect the load side with this instruction. So case 1 says that we need to connect H1 and H5. So what does it mean? So if you look at our transformer setup, so we have the initial point is H1, and second point is H2, H3, and H4, H5. So there are several points, and we need to actually connect this to in order to have this long length of windings. So we're going to do that. We are going to connect according to this instruction. So case 1 is saying that we need to connect H1 and H5. That means we're going to connect H1 and H5 like so, and definitely we need to connect this H3 and H4. On the secondary side or the load side, we need to connect X1 and X2. So this is X1 and this is X2. So we're going to take only these two. So we'll test every possible combination here. That's why we're going to test total 12 different circuit arrangements. So this is the setup. So now everything is on. I will be turning this switch on of this section, and okay, the secondary is connected to this power analyzer, and it is connected to this load, which is R load, simple R load, and the power supply is connected to the primary of this transformer to this through this power analyzer. And it is to be mentioned that not always. For this experiment we are gonna use primary and secondary setup. Sometimes we'll supply to the primary, and from this primary we'll take output. So since we are talking about auto transformer, so we are gonna test maximum possible combinations here. So let's turn this on and supply 50 volts. We are not going to supply more than 50 volts. We could supply more than that, but it's okay for the timing. And for this experiment, the most important thing is supply voltage and the output voltage. So although in this table you may see we have primary side voltage, primary side current, primary side power factor, secondary side voltage, secondary side current, secondary side's power, and cos theta of the secondary side, power factor of the secondary side. And finally we have this calculation which says Vs over Vp. So we're gonna divide Vs with this Vp. So these two are the most important parameters here, Vp and Vs. We need to actually make sure that they are correct. So we are supplying on the primary side or the source side with 50 volts. The power is 0.1, power factor is 0.283, voltage supplied voltage is 50, and current is 0.007. On the secondary side, the power is 0.3, power factor is 1, voltage is 2.5, and the current is 0.007. So that's the first case. I'd like you to actually make a chart like this, table like this, and put all those values. Now we are gonna what is it called, remove this voltage source. So we'll make it 0, and we'll go for case 2, where it says the primary side or supply side which will be H1 and H5, which is the current state, and the secondary side will be X1 and X3. That means we are gonna change this blue from X2 to X3. And now we are gonna supply same amount of voltage, which is 50. Okay, so with this arrangement, the input power is 0.2, power factor is 0.449, or you can say 5. Supply voltage is 50.4, current is 0.008. On the secondary, the power is 0.3, power factor is 1 since it is a resistive load, and the voltage is 4.9, and the current is 0.015. Okay, now we'll look at case 3 now, where the supply side remains the same, load side is changing. So X1 and X4. So we're gonna remove this one. Before that, I need to reduce the voltage, so we're gonna remove this one and connect X4. Now we're gonna, so the voltage is 0, we'll improve it, we'll increase it till it reaches 50. Okay, yeah, okay, so 0.6, power factor is 0.879 or 8, power voltage, supply voltage is 50.5, current is 0.014. On the secondary side, it will be 0.7, the power factor is 1, voltage is 12.4, current is 0.37. So we'll proceed to the next one, which is case 5. So the primary side is the same. Now we are gonna remove the secondary and we'll change it to, we'll connect the load to the primary. So let me dial it off. We're gonna remove these two and we'll connect on the primary side. So this is actually the auto transformer we are going to actually examine now. So if we look at case 5, it says the starting point is H1, supply side is H1 to H5. That means the whole winding we're gonna take to give the supply, and the load side will be H1 to H2. That means H1 and H2. That tells us that the connection would look like this. That means we are supplying through these two green banana cable. These are the supply, and these blue, these are the load side. That means we are going to actually use the fraction of the whole winding. So if the winding starts from H1 and ends at H5, so basically we are using a fraction of the supply. So this is a classic example of step down auto transformer example. So we are gonna increase the voltage, and we will see we'll go to 50 volts. So this is 50. Input power is 0.2, power factor is 0.4, input voltage is 50.4, current is 0.009. And now look at the load side. 0.4 is the power factor is 1, and voltage is 6.6, and current is 0.020. So from this arrangement we can say that the secondary would be low, but with the actual value we can actually calculate by using this formula, this formula, we can say what's the transformation ratio for this transformer, for this arrangement. So now we'll go from case 5 to case 6, sorry, case 4 to case 5, which is H1 H5 as the supply, and load is H1 H4. So I apologize, I have been actually calling this case 5, the previous one case 5, but it should be case 5, sorry, case 4, and now we are going to do case 5. So we're going to actually reduce the voltage, and we will change the connection like it says H1 to H4 on the load side. So we'll connect H4. Basically what it means is we are actually connecting H3 and H4. They are the same point. So basically we are connecting H3 and H4 all together. So let's increase the voltage. So the volts will be 50. Okay, that's about it. So it is 2 watt, power factor is 0.946, supply voltage is 50.4, output input current, supply current is 0.042. And now let's look at the load side, which is which gives 2.1, power factor is 1, the voltage is 24.9, and the output current is 0.075. That means if you look at this primary voltage or the supply voltage, it is 50.4, and the secondary side or the load side, the voltage is 25. That means the transformation ratio is exactly half. Now we'll go for case 6, where we can see it says the supply side will be connected to X1 through X1 to X7, and the load side will be X1 to X4. So I will remove everything from this connection because we are not going to use any H's this time. So what we are going to do is we'll disconnect it and connect X1, since X1 will be is common for both supply side and the load side. And for this one, X7 supply side, and let's bring it down, this one, X4. So we are going to connect X4 and this. So that's about it. Let's go back to case 6 again. The supply side should be connected to X1 to X7. So these two greens are connected from X1 to X7, and load side is connected from X1 to X4. So from X1 to X4. So now we will increase the input voltage, so from 0 to 50. Okay, so input power is 2.5, power factor is 0.9, voltage is 50.4, current is 0.54. On the load side it is 2.1, power factor is 1, voltage is 25.1 as expected, and input power load current is 0.075. Now we'll go directly to case 7. So H1 to H3 for the power supply end, and the load side it is H1 to H5. So let me dial the voltage down and switch it off. We'll remove every connection here, because in case 7, like case 6, in case of case 6 we used only the secondary portion. Now we are going to use only the primary one. So supply voltage will be from H1 to H3. So we are going to use this half of the winding of the whole winding as the supply, and we'll take if we look at the secondary side, H1 to H5. So we'll connect this one, and we'll connect this one. So secondary will be connected to this one, not secondary, like I mean the loads are connected to this one right now with this configuration, but we need to make sure that these two are connected, otherwise there won't be, if there is no electrical connection between them, we will not get any voltage or current or anything. Now with that setup, let's increase the voltage, supply voltage. So the supply voltage should always be 50. So input power is 30.6, power factor is 0.99, supply voltage is 50.5, current is 0.6 ampere. Now if you look at this, the input power is almost same, 28.8. that means there are some losses, core loss and copper loss. Power factor is 1 because we are using only, what is it called, resistive load. Voltage is 97.8, and load side current is 0.292. What does it tell us? So look at secondary and not secondary. I keep on saying secondary. We could say that it is secondary, but it's better to call load side voltage, which is 97 or 98, and supply voltage is 50. So that means the transformation ratio for this case is 2. That means we are this is the first time we are actually encountering step up case. Initially from case 1 to case 6 we saw step down, but now we are seeing step up. So now we are gonna reduce the voltage to 0 and see the last one, case 8. So supply is from H1 to H3, and the load side is from H1 to H4. So we are going to actually connect it like this. So the supply end was exactly like the same, so it is exactly like the same, and we have changed the load side. So it was previously 8 at this point, we change it to and connect it to H4. Now we are going to increase the voltage. So the voltage is this much. So power on the supply end is 8.4, power factor is 0.978, my supply voltage is 50.48 and current is 0.169. On the load side the power is 0.8, sorry, not 0.8, 8, power factor is 1, it's 50.8, and the current on the load side is 0.152. Why is the voltage is exactly like the same one? It is because we are actually literally we are taking power, we're supplying power at this point H1 to H3, and we are getting power or the voltage from the same point. So H3 and H4 are literally same point, so that's why the transformation ratio for this case will be 1. Now we'll go back to the table and let's go for case number 9, which says the supply will be from x1 to x3 and the load side will be from x1 to x5. Okay, we'll remove every connection from here. So the supply is from x1 to x3. So x3, this is the supply end, and what is the load end? X1 to x5. So load end will be from x5, but we need to connect this two first. So the load end should be connected from x1 to x5. So let me double check: x1 to x3, x1 to x5, x1 to x3, and x1 to x5. That's about it. Let's increase the voltage to 50. Okay, so the input power, see the amount of power got increased, 67.4, power factor is 0.4, input power is 50.5 50.1, input current is 3.32. Let's look at the secondary side or the load side. It is 46.2 is the input power, power factor load side power factor is 1. So secondary voltage is 123.8, that means a lot, and here the current is 0.370. Now let's go back to the table and see case number 10, which is on the supply side we'll have to connect x1 to x4 and x1 on the load side it will be x1 to x5. So we will remove it was connected here, so I removed it and I will connect it here. So basically it should give us, so the supply is these two end and the load side is this two end, so they are basically identical in terms of turns ratio, because literally this point and this point they are both same. So let's increase the voltage to 50 volts. Okay, so if we look at the power, it is 9.8, power factor is 0.94 or 95, input voltage is 50.1, current is 0.205. Now let's go to the load side. We will see 7.8 watt, power factor is 1, output voltage is literally the same, 50.1, and the output current is 0.150. Now let's go back to the table once again. If you look at case 11, which is the second last one, x1 to x4 is the supply, and the load side is connected x1 to x6. So x1 to x3 or 4, sorry, 6 4. So supply is okay. We need to actually remove, okay, I totally forgot to reduce the voltage. So I'm removing one of the banana cables from the at that point, but we need to connect it here at x6. It says over there, yeah. So now let's increase the volt 50. Okay, with that, okay, it's 51. I need to reduce it a little. Okay, input power is 25.3, power factor is 0.986, voltage is 50.5, input current is 0.508. On the load side, the power is 22.8. Power factor is as always 1. Secondary voltage is, or the load side voltage is 86.9, and current is 0.260 ampere. So which brings us to the last one, which is case 12. So supply is x1 x4, that's okay, but the load side will have to change the load side from x6 to x7. So all I have to do is remove this one and connect this. Now I can guess, and it will happen that the secondary voltage or the load side voltage will increase in this case, because we are increasing the what is it called, the turns number. Now let's increase the value of voltage here. Okay, so now if we look at it, the power is 32.8, power factor 0.99, supply voltage is 50.4, and current is 0.656. Let's go to the load side, which is 30.1, power factor is 1, voltage is almost 100, I would say 100, and current is 0.298. that means it got doubled. So with that, we need to actually, after getting all of this information, we need to calculate this and see in which cases we got step up and step down. In some cases we'll see the power factor, value of power factor is totally different, and in some cases we'll see the power went up pretty rapidly. In some cases we will see that the what is it called, the values are not making any sense. So we'll have to figure it out. We'll have to actually answer those questions. So I will put some questions, you need to answer them. If you don't know the answers, you can ask me anytime. I can give you an explanation for those. So that's all for me today. You have a wonderful weekend. Thank you. Okay, so let me open the slide again. Yeah, so as I just told you guys that we need to actually fill up this one table and do the calculation, and you need to answer some of the questions that I might ask you in the assignment. So you need to read all of this here, and you don't need to answer all of these questions, but I will ask some questions that you need to ask them, those like error analysis, like there will be some mismatched data, measured data, so you'll have to answer them, why are they like this. So you will see some anomalies in terms of like power factor measurement and uh, output voltage, power, input power, output power. So we'll have you guys will have to actually answer those. So uh, again, I'm telling you, you need to include experiment name, number, purpose. You don't need to write discussion or apparatus. You need to write the procedure and the questions that will be given in the assignment section. So that's all for today. If you have any question, you can always email me. Some last week, it was really hectic for me, so I couldn't actually answer a couple of yours questions, but I will be answering your questions. But anyway, feel free to contact me anytime. Thank you so much. Have a nice weekend.